What is up, everybody? Here we are back with another episode. So, today we're going to be talking about the parser, or we're going to be talking about the AST. So, I know I talked about in my previous video, which I probably should stop doing. I mentioned that we were going to start on the parser, and I was going to show you guys how to actually parse like the module declaration or the first part of the file. We're not going to do that in this episode because I realized that I missed an important part of setting up the parser, which is the actual AST. So today we're going to be talking about what an abstract syntax tree is. But before we get to this, I just want to mention something very important. So this programming language, guys, is a work in progress, meaning that it's not done yet. And I know I've said before, like, currently I'm working on the back end side of the compiler, and I know I said the front end part was done. That is about 90% true. I'm still working on the front end though. So, like for instance, I have some code in here for parsing function pointers, which I'm refactoring how function pointers are processed and parsed in the language, and I'm making tons of changes in the compiler as well. So this isn't a finished product, so I don't want you guys to treat it as a finished product. Like I'm still working on every bit and part of the compiler. Um, so try not to be too harsh on me when it comes to like I could see if this was like a finished product and I'm like, okay, here you go. Here's how you do this. Here's how you build a compiler from scratch. But this is more of, like I said, a work in progress. So definitely keep that in mind. But with that being said, let's get into what an AST is. So an AST is very simple. It's AST is just short for abstract syntax tree. And I'm gonna go here and I'm just gonna go to Google really quick and I'm just gonna type in what an AST is. Abstract syntax tree. And basically what an abstract syntax tree is it represents how each token in your language should be like how they should interact with each other. So yeah, I'm gonna see if I can find a really good example really quick. Okay, so here's one. So here's an example where you have like a while loop, and then we're saying while x is less than 20. Well, you can see that this is kind of like a tree, right? So you have your top level tree, and then you have like a branch below it, and each branch has other branches that branch even further. It's kind of like the root of a tree. So like here's the stump, and then here are the roots that the tree extends down into the ground. So you can kind of think of it like that. And that's what an abstract syntax tree effectively represents. So yeah, let's actually see how I do this in the code. So I basically have a list of sub ASTs here. And when I, here, let me go back. So like for instance, this would be considered an abstract syntax tree that would have two sub ASTs, and each sub AST is going to have a specific token. So I also have in my language a list of tokens as well, and then of course I have the type. So we need to know what the type of the AST is so that way we can process it properly. And then we have our tokens which represent the data inside of each AST. So any number of ASTs can have tokens, but typically you want to kind of have this high level structure of how it should be laid out, and then the final AST should have like the tokens of what it actually represents. So yeah, let's actually get into the setup. So the setup for ASTs are pretty short, so that's why it's not in its own video. We're just going to kind of go over everything. So first you want to create, first you want to create like two variables. So you want to know the line and the column. This is very important because this effectively represents the line and the column that the AST was found on. And after that, you want to have, of course, like I mentioned, your list of sub ASTs. Then you want to have an AST type and a list of tokens. Now, you guys know what this is. This is in our tokenizer. And so for AST type, I'm not going to go through all of them. You can definitely copy this if you want, but basically you want to have all of the names of all of your ASTs, and you can possibly do this. This is kind of weird. Don't roast me for doing this, but basically what this is this is a high level construct of what each AST represents. I thought that this was a lot easier when it comes to, this is really only used for processing expressions. For processing things like variable declarations, I mean, I have ASTs for all of that. For processing like interfaces and classes, I have ASTs for that, but expressions are so complicated that you kind of want to, that's what has the underscore E postfix to denote that it's specifically an AST that holds an expression. So you guys can copy that. But yeah, that's what this is. You basically want to create an enum with all of your types of your ASTs that your language is going to support. And you want to get as granular as possible with this. So, AST value represents a value that's being assigned to a variable. AST expression, where is that at? It's somewhere in here. I don't know exactly where it is, but I also have an AST expression for representing expressions that you can pass to, like, I don't know, a function or something like that. And then, of course, I have class decorations, so on and so forth. So you can take a look at it. It's in my AST file, ast.h, inside the parser, inside of the front end, if you guys want to check it out. But yeah, these are all the various different types that we're going to have. And to also be kind of clean, like you want to try to group your stuff together. So like you can see here, I have like statements all grouped together. I have blocks grouped together. I have certain other things like declarations, implementations of things like, delegate implementations and, delegate declarations, enum declarations. So you kind of want to like group your stuff just to make it easier to find things. But yeah, that's just something that I did. So let's go back to the actual, or let's go back down here. So first thing you're going to need to do is create a constructor. This is going to be a quick way to create your AST. So you want to pass in the type, the line, and the column at which your AST happened at. And then we initialize our two lists here. And yeah, that's pretty much it. After that, you want to, of course, create your empty AST, your empty constructor. So that way, if you just want a blank AST, you can just kind of do it that way with no type or anything. Um, and then you can also create a constructor for copying ASTs as well. You just take a pointer and then you just copy the values. So that's all you need to do for the setup. Now let's get into the actual functions. Most of these functions, like you can see, some of these are like not used. Most of these functions I don't like the naming of these. This came from kind of like a legacy version of my compiler 1.0, so I haven't really made too many changes to the AST, but let's just go through them. So first you have encapsulate. This is a complicated topic. What this effectively does is, let me go back to here. So like, let's say you have two ASTs here and you want to represent it as this times AST. Well, these two ASTs currently are inside of plus. So if you want to put it in times, you can basically add an AST of times to the end of this, and then you can encapsulate these values into this AST to kind of do it that way. So let's actually, I know it's a bit confusing. So what it does effectively is you create an AST of AST type whatever, um, and then it effectively takes, so it creates a new branch, and it creates a new AST, and it sets the type here and then the line and the column. And what it does is it basically goes through and adds all of the ASTs that the instance has, all of the sub ASTs and then all the tokens. And then it basically frees up this entire AST and it adds this branch to the end. And considering that this branch wasn't a part of the list, you can just delete everything and then just add the branch to the end and then you return the branch as the encapsulated AST. So it allows you to like I said, basically encapsulate ASTs inside of each other. So that's a little bit handy. I don't like this approach personally, but because I'm trying to move along with the series, this is just what I have right now. So that's what I'm gonna have to show. Let's go back. All right, so next, of course, we want to have like simple functions. I mean, these are pretty self-explanatory. You want to be able to get the type. Ideally, you don't want like your information to be publicly accessible. This was publicly set to publicly accessible because reasons I don't remember, but ideally, it's just good programming practice to have your stuff not publicly accessible and use getter functions and setters to modify the data. But of course, you want to be able to get your type. You want to be able to get the count of the sub ASTs or how many sub ASTs you have. You want to get a sub AST at a certain index, which this is completely pointless to do that check. So I'm going to remove that. As you can see, I'm like updating code live. This is really old code. I haven't updated this in years. But yep, so you also want to get the entity count, which is a bad name. I'm going to change this live as well. I'm going to get the token count. A long time ago, tokens were called entities for whatever reason, so that's why it was called that. Um, okay, so I got to change this one as well. So you also want to be able to get a token at a certain index, so you want to be able to do that. Let's wait for this to finish here. Okay, that must have been used in a lot of places. After that, you want to be able to add a token. So like you can add a token by passing in an entity. As you can see, it's called an entity still for some reason. After that, you want to be able to add an AST. This is pretty self-explanatory. Just add it to the list. You want to also be able to add a first AST. I'm just going to delete this. I don't think I need this. But the idea is that you want to create as many helper functions for this class as you want. So that way it's just easier to interact with it. Of course, after that, you want to have your free. So you want to be able to free up the AST. So you want to go through each AST. You want to call free on the actual AST, and then you want to delete the AST. So here's something important to note. If you're programming in C++, you can only call delete if you call new. So like the assumption for this free function is that whenever we create an AST pointer, we're effectively saying PAST is equal to new AST, right? So this function is expecting that this is how we're getting the address or getting instances of ASTs. So that's why we're using delete. If you do something like equals AST pointer and then you do like a malloc, and then you do like the size of and everything that you need to put inside of here, that's really bad because C++ doesn't like that because of how it allocates. So just be aware of that. Obviously, you want to clear out the type of your AST and free your token list. So there's that. Next, you want to free your sub ASTs. So there might be instances where you don't want to free up your tokens that your AST has, but you just want to free up the sub ASTs. So that's what this does. It just frees up all the current sub ASTs that the abstract syntax tree holds. Sometimes you just want to free the last sub AST. So again, same thing. You just want to do that. So that's really handy. We'll go over that. Freeing a specific AST. I'm going to delete this one as well. Also freeing the last entity. Let's go back. Okay, so I'm going to delete this, and rename this to free tokens. So as you can see, like I said before, this language is still a work in progress. I'm still changing things. It's not 100%, but it's good enough to where I can show you guys. So after that, you want to check to see if you have a sub AST. Now this, I use this everywhere. This is a function that you're going to be using on the compiler side. So once you get to like the back end, once you populate all your ASTs, you want to be able to check to see if it has the AST you're looking for and return true if that's possible. So you of course call the get type function on the AST. I know these variable names are bad. Um, yeah, I'm aware of that. um, but next, we want to check to see if we have a token. This is also very helpful. So you can check by the token type, right? So if you have like equals or whatever, you can do that. After that, you can also check to see if, or you can try to get a sub AST. So what this does is it basically checks to see if you have the AST, like for instance of AST class declaration. And if that exists, then it returns that AST. Otherwise, it returns null. So technically, you could, replace this and just not have has AST and just check to see if this is null. I just felt like, it's fine to have both of them. Based on your personal preference, you can have one or the other. After that, you want to be able to get a token based on the token type. I think we reviewed that. Did we not? I feel like we did. Oh no, it was has token. Okay, so I have a has token, then I have a get token. This is important because if the token doesn't exist of that type, it returns a new instance, and we don't want that. So just to not be wasteful, that's why I have the has. After that, we have get next sub AST. I'm going to delete that as well. Okay. So we already went over encapsulate. Now this one's very important. So we have AST type to string. Um, Here's a nifty trick that I want to show you guys. This is really cool. So when I wrote this function, I mean, this is a huge pain in the butt to write. And I started out writing these one by one, and you literally just copy this and paste it into a string. I found out a fast way to do it. So if you go here, you can literally, here, I'm going to run through a quick example really fast. So you can go here, if you do a left click, you can say column select mode, and you can literally do this. So I'm going to go here and do a column select mode, and you can literally just like copy this, go back to the actual AST, and I'm going to go here and I'm going to disable column select mode. So if you hit the center button on your mouse, you can hold it and you can do something really cool. So you'd copy it again, so you do something like this, and you scroll all the way down, you copy it, then you'd scroll all the way back up to the top, then you can like do this, put case right here, and then you can, again, holding the middle mouse button, you can get everything, like make sure that the cursor is right in front of it. You can do, put the little colon there, hit enter, type return, space, or put the little quotation signs for the string, and then paste everything in. And that's how I was able to do this function. That is so, like, it was so easy. It took me like 5 seconds. So that's something really cool that I figured out that you can do. You can only do this with C Lion. I know IntelliJ products like Android Studio or just regular IntelliJ, anything made by them, I think you can do it. It's like a functionality that comes with the IDE, so definitely check that out. But that really sped up creating this function. But what this function does is effectively returns the, as you can see, it converts the AST type to a string, and this is extremely important. So this is what we're going to use for unit testing. So I'm going to talk about unit testing your parser at a later episode, but yeah, we're definitely going to need this function. So I'm just going to scroll down here. After that, you want to be able to set the type. So I mean, this is self-explanatory. You just update the type in the actual instance. After that, you want to get the last sub AST. I feel like we did this already. I don't know. I feel like we did this already, but basically, it's what it does is it just gets the last element in the list. So yeah, and I think you don't even need to do that. So yeah. All right. So it gets the last element in the list, and then after that, we have our copy function, which you saw earlier. So we free up the current AST. We then check to see if this parameter is not equal to null. And then we just copy everything. So we copy the line, the column, the type, we copy all of the sub ASTs, and we add all the tokens. That's what we do for that. After that, we have has token. Okay, so what this one is this is actual string. So there might be cases where like, I don't know, you might want to check to see like you might have, so like I have like this token type here where it's like a dot or a hash. That's fine, but like what if you want to see if it has the token like, I don't know, base, right? If it has base, because you know that a base class comes after that text, so you want to check to see if it actually has that specific token. So that's important to have. So we have that. After that, you want to, so this is the last thing that we have. So after that, we have our unit testing functions. So we're going to go over this in a later episode. I'm not going to talk about this right now. I'm not even going to go over this too much. But basically, we want to get the indent, and we basically want to print out in a structured format how our, like what data is inside of our ASTs. So here, I'm just going to run this really quick just to show you guys. It's really, really cool. It definitely allows you to see how things are laid out in the actual code. So I'm going to do something here. So I'm going to come back, and when I come back, I'll show you guys how it looks. All right, so I made a quick example here, and what it basically does is we're going to create a class house, and we're going to have a variable called windows, we're going to have a variable called has basement, and we're going to have a variable called open. And I'm just going to print out what the parser actually generated. So I'm going to run this really quick, and we can actually see what ends up happening. So again, like I said, this is kind of used for like unit testing, so it's not something I'm going to go into for the purposes of this episode, but at least we can see what the console returns. So we can see here, and let's actually go back up here. This is really, really useful, especially when you're actually on the compiler side, because you get to see the output. So you can see here, I have a class declaration. The AST is AST class declaration. It has one AST or one sub AST. It has tokens called house, and then it has the open brackets. Then it has a AST block, which has three ASTs because this is one AST, because this represents a variable declaration. This is another AST, and this is a final AST. So we can see here we have a variable declaration called windows, and we can see it has also this character and this character. So it has both of those. And this is important. You don't always need to have these tokens inside the actual AST. I mean, you know it's a variable declaration, so all you need is just a name. So you need this token, but you don't really need these. But there are certain cases where you need them, and we'll go over that in a different episode. But yeah, let's keep going. So then you have what's called a U type, which we'll get into later as well. And then it's basically int 8, so that's the type of this variable. You can also see here, this variable is a little bit more complicated. It uses type inference, so it has like this type inference here. You can see it's an expression. This one above didn't have that information. It was just a basic variable with a type. So there's an expression, there's a primary expression, there's a literal expression, that hence the AST literal E. Um, and then you have your AST literal, and you have the actual value, which is false. Um, Finally, below that, you can see we have a method declaration with three ASTs. So it has a reference pointer, which is just the name of the actual function, because my language supports what is this called, extension functions. That's why I have a reference pointer. That's why it's not just a standard like identifier like up here. Um, so there's that. Then you also have the ASTU type arg list, which basically represents this. So like let's say I had like a variable here called force unlock or something, and we set that to a bool. Let's pause, or let's stop this. Let's rerun it. Um, Whoops, and let's go back, class declaration. All right, so if we go back to our actual file, we can see here we have our utype args, then we have force unlock arg, then we have the utype, which is Boolean, and you can see that they're reflected. Then finally you have your block. We don't have anything in there yet because we don't support statements yet in my language. I'm getting to that. I'm still working on a fix for that, so that way I can show that in the YouTube series. But yeah, so I just wanted to go over how to actually create an AST, and we can circle back around to looking at this when it comes to doing unit testing in the actual language later. But yeah, that's it. So hope you guys enjoyed the video. As per usual, if you guys would love to stay up to date with the language, definitely check out the GitHub repo here. You can watch Star and Fork It. This is the actual repo where the language is actively developed, and you can check out both the master and the remastered branch. Anything else is pretty stale. The remastered branch, however, is what I update on almost a daily basis. This is where most of the development is going to be happening, and anytime I push a release for Sharp, that will go towards the master branch. Also, if you want to have a more detailed look into what's going on in the language, definitely check out the docs folder. You can check out the changeless folder for all the changes that I've added to the language in previous versions, and you can check out the roadmap file or the roadmap page where I'm basically writing out everything I want to either add to the language including also things that I've already done to the language. So definitely check that out. But hope you guys enjoyed the video today. Definitely like, comment, and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.